Welcome, everyone. Just going to give you a very brief overview about this, what's been happening with the Harvard Center for Green Buildings and Cities, as well as the Center for the Environment and the Climate Week. As you know, the Harvard University Center for the Environment, in collaboration with a wide variety of partners, institutions across Harvard campus, has organized a week on climate change-related events called Climate Week. This week-long program will give Harvard community as well as the interested public exposure to some of the best scholars and thinkers related to climate change, hence our speaker. So on behalf of the Harvard Center for the Environment, as well as the Harvard Center for Green Buildings and Cities, I'm very delighted and honored to present to you our speaker, Bud Rice. Bud's careers in environmental policy and nonprofit leadership spans more than 40 years. Very distinguished, long career. Currently, he co-chairs the Climate Preparedness Working Group of the Green Ribbon Commission and is an advisor to the Barr Foundation. Bud has been actively involved in the design and implementation of the Climate Ready Boston project, which focuses on making Boston a more resilient city. From 2005 to 2014, Bud served as president and CEO of the New England Aquarium, where he had led a successful multi-year campaign to renovate the institution's signature exhibits and strengthen its programs on marine conservation. Under his leadership, the aquarium launched a nationwide education program on climate change that now includes more than 100 museums and aquariums. Prior to that, Bud was a senior fellow at the World Economic Forum in Switzerland, where he led the Davos Group program on climate change for the UK Prime Minister Tony Blair. From 1984 to 2000, Bud served as the Chief Executive Officer of the Union of Concerned Scientists, which has long been in the forefront of research, education, and policy advocacy on climate change. Bud is a trustee of Boston Harbor Now and the Greenway Conservatory, and has served on many advisory committees for the City of Boston and Commonwealth of Massachusetts, focused on climate change and waterfront developments. In 2014, he was honored for his leadership on behalf of the New England's environment by the U.S. Environmental Protection Agency. So on behalf of the GSD, the Center for the Environment, the Harvard Center for Green Buildings and Cities, we welcome you back at the GSD.
Thanks, Holly. So you're probably wondering, what the hell did he do at the New England Aquarium with that trajectory? And it's a long story, but I'll shorten it by telling you on one trip to Geneva to work on climate change, I sat next to the chairman of the New England Aquarium, who roped me into being the CEO there for 10 years. So, but it was a lot of fun, and there was actually a pretty deep connection because the oceans are very much on the front lines of the impacts of climate change. And so the aquarium, most people think of it as in terms of what happens down on Central Wharf, but they actually have a lot of global research and conservation work, a lot of which focuses now on climate. So it was actually a pretty good fit. But most of my life I've spent working on the mitigation side of climate change. There are sort of two big tracks. That's the mitigation side, cutting greenhouse gases to try to reduce the problem. And now there's the adaptation or the climate preparedness side or the resilience side, which is now that we have this problem, how are we going to deal with it? And so most of my life, and somebody introduced me about 6 or 8 months ago as saying, Bud has worked on this issue so long that parts per million in the atmosphere of carbon have gone from 330 to 402, which means Bud hasn't accomplished a whole lot in 40 years. But I have been involved in this issue for quite a long time. But when I ended up in the aquarium, as you'll see in a moment, it became pretty clear that any map that was going to show potential flood problems in Boston was going to show the New England Aquarium as being in the epicenter of that dangerous zone. So we got interested in this issue pretty early on, and we can come back to that later on. But I was a member and still a member of the Green Ribbon Commission, which is a consortium of about 35 CEOs from the private sector, many of them in the commercial real estate sector, in the financial world, and also CEOs or senior executives from the universities and the health institutions here in Boston. So it's a really interesting group. It also came together first to work on mitigation to help the city of Boston green itself. And then in the last few years also decided to take on this whole issue of adaptation or resilience. So we put together a working group of representatives from those various members of the Green Ribbon Commission, formed a partnership with the city, helped design and then raise some money to launch this very big project, which was $1 million project led by the city in partnership with the Green Ribbon Commission. And then we hired a group of consultants that ranged from a scientist team at UMass Boston, HRNA advisors in New York, Arcadis, which is a Dutch engineering firm, Sasaki, which is a firm that I'm sure many of you are familiar with here, architecture, landscape architecture, and some of the communications work were done by a firm called Ink House. So it was a really pretty large project with a lot of people working on it. And it was completed in December, phase 1, and now phase 2 is underway. So what I'm going to do is talk to you about the principal results from that project, and then talk a little bit more about what's now happening in phase 2. But first, one of the things I've learned, I'm working on this issue for 40 years, is stop depressing people. So let me start with a little bit of history and maybe give you a little bit of hope. Is there anybody here who is not that familiar with the geography of Boston? I can't see a thing, but rough idea? Okay, well, that's Boston Harbor on the left and the right. As many of you probably know, because you're maybe in the design fields, a lot of Boston is what we call fill, but back then was called made land. Done over 400 years. Boston's about to celebrate its 400th anniversary in 2030. But the drawing on the left shows you Boston as it was in 1630 in the white, and then all that land that's been filled, and then you can see how it evolved here on the right. So implant that map in your head, and particularly remember this little hook up here in this part of town. This is the North End where I live, and this is Beacon Hill, and that was the original city, and you'll see why that's important in a few minutes. Today, Boston, of course, has a booming waterfront. Everybody hear me all right? Great. Booming waterfront, that's the seaport area on the left. We actually have the first church now built in Boston in 60 years. It's the Lady of the Good Voyage. I call it the Lady of the No Flood, and you'll see why in a few minutes when we come back to that. That's downtown Christopher Columbus Park on the right, very, very active. And of course, the Boston skyline with the world-famous New England Aquarium right there. So. We have a history of some problems that relate to climate change, and I'll spend most of the rest of the talk coming back to this particular topic. On the left, you see a chart of the level of Boston Harbor going back almost 100 years, partly because Boston has subsided, but partly because climate has already started to elevate the level of the harbor. Boston Harbor is now about a foot higher than it was 100 years ago. I think it's 11 inches to be exact. There's a tide gauge, which is one of the oldest tide gauges in the country, over by the Northern Avenue Bridge. And we are, of course, on the path of tropical hurricanes, but we've been spared many, many times, partly because the big elbow of Cape Cod provides a great deal of protection. And then just outside Boston are 35 islands, which in the outer harbor, which dissipate wave action and protect our city. And also because a lot of the storms come inland. We've tackled some very big problems before. Those of you who may be familiar with the Big Dig, that's now the Greenway, and I forget what the price tag is. It's somewhere between $15 billion and $22 billion. But it's now a very lovely part of the city. And of course, on the right, Boston was at one time the dirtiest harbor in the United States, and now it is the cleanest urban harbor in the United States. Very big challenge, a $6 billion project. There is no shortage of good ideas. There have been 5 or 6 competitions in the Boston area. Probably many from this school have participated in them over the last 5 years, coming up with various ideas on, how to protect the waterfront, but not only to protect it, how to add other beneficial uses and provide good public benefits that are tied in with the community in the process. The one on the right is actually in a place called 100 Acres, which is about 25 feet from where GE's new world headquarters will be in the Four-Point Channel. And we can learn a lot from other cities. That's Amsterdam on the upper left. The Green Ribbon Commission led a trip to the Netherlands and Denmark last spring. We took 20 public officials to learn about how those cities are coping with this big challenge. It's interesting to note that the Netherlands as a whole, 60% of the GNP of the entire country is produced below the level of the sea. They have had 800 years to work this out, but they've done a pretty good job. And then New York is now one of the pioneers in terms of design solutions. They, of course, had the special impetus of Sandy. This is the proposal for Big U at the base of Manhattan, which essentially is a very large berm that's elevated that would have, if all goes well, a fantastic new park and other uses integrated with it and would protect lower Manhattan, which was hit very hard by Sandy, 3 or 4 years ago. So there's hope. Other places are dealing with this problem. We're now getting focused on it, and we are only one of 2 major cities in the United States, San Francisco being the other one, that have not yet had a Katrina or a Sandy in our recent memory, but are trying to get ahead of this problem. So in many ways, I think we should be very proud of our city forefathers. This started under Mayor Menino and now under Mayor Walsh to try to look at this problem in advance of having a dangerous storm. So our study had really 3 major parts. One was to update the science about what will happen in Boston, and I'll spend a few minutes on that as our climate change is going forward. Secondly, to look at what, who, and where, and what its value is that would be affected throughout the city by our changing climate. And then thirdly, to come up with a series of resilience initiatives which outlines an implementation roadmap of policies and strategies for the next 5 years for the city to embark on. So I'm going to go through some of these, each of these areas, and then I'll talk a little bit at the end about some of the new work that's now gotten started. So first on the science, we put together a group of about 30 experts led by a team at UMass Boston. There were scientists from Harvard, MIT, Northeastern, BU. One of the great things Boston has is a wealth of expertise on the climate and the marine world. So we were able to draw upon that. They spent about 8 months updating our knowledge and science about what's going to happen more specifically to Boston rather than the globe or the nation as a whole. They looked primarily at temperature change, precipitation change, and the sea level rise problem. I'm going to show you 3 or 4 graphs, and they're quite simple, but they all have a sort of worst case, best case. The worst case is the top of the graph, the trend line. The best case is the bottom. That's partly because of uncertainties in the science, but it's more because of uncertainties about whether the world will actually get serious about climate change and mitigate the problem. So if we mitigate it as a global community, reduce the gases that cause climate change from going into the atmosphere, you end up on the bottom of these curves. That's the best case. If we continue business as usual, you end up on the top trajectory of these curves. Make sense? So there are uncertainties in the science as well, but most of the uncertainty here I think is more in this particular area. So first, in terms of temperature, Boston historically over the last couple decades has about 11 days above 90 degrees. We're looking at something like 20 to 40 by 2030 and 25 to 90 by 2070. That 20 to 40 days is the climate of Baltimore and Washington. 25 to 90 is more like Birmingham, Alabama, or Miami. A very, very different city than what we know today. If you're wondering where we are in that trajectory, we had 22 days above 90 degrees last summer. That has all kinds of implications that I'm not going to go into for the built environment that you could easily probably imagine. Boston will also get wetter. This graph maps what's called the 10-year, 24-hour design storm. Those are episodes during the year of severe rainfall, very heavy precipitation. We have about 70% more of those now than we had 50 years ago. So if you've walked downtown, you'll already notice the puddles are deeper. There's more water. The rain is more intense, which creates all kinds of problems for drainage. Our group felt that what now is about 5.5 inches will increase maybe 20% or so over the next several decades. So more intense rainfall. That has implications for more the inland areas around the city. About 70% of the buildings that will be exposed are small residences, a lot of them 2- and 3- or 4-decker houses, where this flooding will be a big problem. There's another 50 slides that go with that one. I'm not going to go into it, but you can go online and learn more about it. I'm going to focus mostly on sea level rise and the flooding vulnerabilities from that particular problem.
Will you give us the URL where we can go online?
Yes, I will at the end. And I'm going very fast because I want to get through the grand sweep of all this, and then I'm happy to take questions. But if you get confused, I can't see a thing unless somebody can turn the lights down up there. But shout at me if you don't understand something, and I'll stop, okay? So why is the sea rising? Two primary causes. One is thermal expansion. As you heat up a liquid, it expands. So if you heat up the entire oceans, the oceans expand, and that water will rise up because it can't go anywhere else. Also melting from glaciers in mountainous areas, whether it's the Himalayas or the west of the United States. And then melting of ice from Greenland and Antarctica, where the ice sits on top of landforms on top of continents. Arctic ice melting doesn't contribute to this problem because the Arctic ice is like your ice cubes in a cocktail glass. It's floating in water. It's not on top of land. So it's important to understand that. The loss of the Arctic ice will have other problems that are not good, but in this particular case, it's not a big contributor to sea level rise. Our problem, if you remember my first slide, is we built all that made land only 1 foot or 2 feet above sea level. So if you look, for example, at Columbus Park downtown, that's all fill, all made land. That's not even at high tide in that photo. Maybe there's 2 feet till the water's going to be lapping, over the side of the seawall. My house is behind the brick building in the middle, and I'm 1 foot above the 100-year flood storm, happily. So, this is a complicated chart, and I have a simpler one that follows, but I just want to show it because it demonstrates the level of precision that this scientist group was comfortable doing for this particular work. It's really a 3-dimensional matrix. On the left side are 3 different climate scenarios. The 2.5 on the bottom is the world gets very serious about climate change and reduces greenhouse gases. The middle horizontal group are a sort of moderate scenario of greenhouse gas reductions, and in the top is that worst case. We don't do much about it, and we continue to put a lot of the gases in the atmosphere. Across the top are probabilities. So in the middle where it says 0.5, that means everything below it has a better than 50% chance of happening. So all that boils down to this more simple graphic that shows in the dark bar is a probability of 2 out of 3 that we will see a range of 4 to 8 inches of sea level rise by about 2030, just 15 years from now. The baseline is 2000, so we've already had a couple of inches since 2000. 2050, 7 inches to 1.5 feet, 2070 up to 3 feet, 2100 somewhere between 2.5 and 7.5 feet, with even the possibility of 10 feet. So if you remember that earlier slide where we had a couple of feet, a lot of Boston, looks like that and faces a real problem going forward. We ended up picking 3 scenarios, partly because of this and partly because we had modeling data. So all the maps I'm going to show you talk about 9 inches of sea level rise, 21 inches, and 3 feet. But keep in mind, there's a worst case that's much possible, more that's even possible. So what does this look like for the city of Boston? And one other thing that our scientist group concluded is that we do not yet have evidence to show whether or not hurricanes are increasing in their intensity or frequency, nor do we have evidence to show whether those kind of changes are taking place with the kind of northeast storms that we get in February and March. So we made no assumptions about whether the hurricane regime is going to change in the maps that I'm going to show you. Our group generally feels, as I think the larger community of scientists believes, that hurricanes are likely to get more intense going forward, but we don't see that happening yet. So we did not include any scenarios for that. So these maps show you what happened if you add 9 inches to the level of Boston Harbor near term, and then I have another 21 and another 36. They show the flood that has the lightest blue is a flood that has a 1% chance in occurring in any given year. The next darker color is a flood that has a 10% chance of occurring. And then we also mapped, the tides shift every day and every month. We have some days where the tide is the highest time that month. We took the average of those high tides across the year and added these increments of sea level rise to that to show what is called nuisance flooding would be like that begins to happen on a monthly or even a weekly or maybe a daily basis further out in the future. So, near term, and 2050, say 30, 40 years from now, we look at maybe 50% of East Boston, a good fraction of Charlestown, and then a really growing fraction of the seaport area where a lot of development has now taken place. And then you start to see a little bit down here in Dorchester where the floodwaters come in as well. But by the end of the century, or sometime after 2070, it begins to look like a very, very different city than what we know of today. And do you remember that hook I showed you on the earlier map? There it is, and Beacon Hill is right in this area. What does begin to happen here, of course, you get very severe flooding in the seaport area, downtown Boston, and I have some more detailed maps that I'll show you in a few minutes, and East Boston and Charlestown, but the water also starts to come in through the Fort Point Channel and begins to expose all of the south end to flooding towards the latter part of the century. Still with me? Hopefully not depressed yet, right? Yeah, so keeping in mind we didn't model any changes in storm regimes, what does happen simply because the level of the harbor is higher, and if you overlay the existing storm frequency and intensities we have on top of that, what today has a 1% chance of annually occurring by mid-century and sometime thereafter becomes the 10% storm, and then sometime after that becomes monthly and even weekly and perhaps even daily as we go forward. So flooding starts happening a lot more frequently. So you end up thinking about not just planning for the storm surge, but also thinking about what happens when the water starts lapping against the side of your building once a month or even once a week or thereafter. A very, very different problem. We did a vulnerability assessment citywide, looking at where people live and work and how they would be affected, what buildings would be affected, and what is the current real estate value of the damage that might occur in those places. We mapped each of these 3 different time periods, which was essentially the 9 inches of sea level rise, 21 and 36, and then the beige bar graph that you see here is that monthly high tide also mapped. And if you boil all of that down, just 15 to 20 years from now, we're looking at maybe 18,000 people, 22,000 buildings, and damage valued at about $20 billion. That's pretty much just damage to the first floor of those buildings, and assuming 3 or 4 weeks out of business or needed recovery time. And then by 2070 and thereafter, 85,000 people, 12,000 buildings, valued at about $85 billion. So the cost-benefit side of the equation is pretty clear. The avoided damage is pretty significant here in Boston, as it is in other East Coast cities like New York, Miami, Norfolk, Virginia, et cetera. Still with me? Then we annualize that. So, if you multiply the storm frequency by those sea level rise scenarios, what does it look like on an annual basis? And if you just look at the third column, sometime around 2070 or thereafter, you begin to see almost $1 billion a year. That's $1 billion annually from those storms that have a 10% chance of occurring. And what happens, if you remember the chart that went from 1% to 10% to monthly, the damage from those more frequent storms becomes a bigger problem than the storms that have a less chance of occurring. So you need to think about that as you're planning for the future. We also looked at critical infrastructure. One of the questions I get in talking to the real estate community all over town is, I can fix my building, but if I can't get there and my people can't come to work and I can't get water and I don't have sewers, I don't have power, I don't have communication, what's the point? So it was really important to look at infrastructure. I won't spend a lot of time on it, but one of the pieces of infrastructure that is particularly problematic is our transportation system. And those of you who take either the Silver Line or the Blue Line will know that many of their stations are right along the waterfront. And they become very vulnerable in just a very short time as we go forward. The good news is the Mass Department of Transportation is probably one of the leaders in the country in studying this problem and beginning to work on it. The challenge ahead is if we got to fix the T to make it work better, we got to make it more resilient as well. This is a graph we got from NSTAR, working with them, showing where power out, it's the duration of power outages, so it identifies areas that are particularly vulnerable along the waterfront, where if they are exposed to flooding, you could have a really long recovery period till they get back into business. I don't know if anybody saw the Globe article yesterday or this morning, was it? They featured the new substation that NSTAR has built in the Seaport area. It's elevated 15 feet, which is good foresight on their part. So let me show you a little bit more specifically different parts of the town. Again, the world-famous New England Aquarium, Harbor Towers, and International Place over here. See the aquarium now, you can see why I began to worry about this problem, because you know, this is Faneuil Hall is right in here. The floodwaters, even in this early part, you know, the first half of this century, may encroach this far. Lewis Wharf, some of the old historic wharfs here are all threatened. And then there's area of growing concern on the harbor side of the Charles River Dam that connects Charlestown right in here. You can see what it looks mid-century and then later. And then a real serious problem by the end of this century. And again, this dark color is monthly tidal flooding, the highest tide each month. So you really need to start thinking about, you know, how are we going to deal with this problem when we have particularly long stretches of the waterfront, and I'll come back to that in a moment. About half of the population will be exposed to flooding in downtown Boston, more than 1,000 buildings, and $3 billion in economic losses that will occur. And that, again, is just sort of first floor damage. Seaport area, which is the booming part of town right now. This is a photo from the water looking right through the center of Fan Pier towards the inland part of the Seaport area. This was entirely made land, entirely fill. Up until about 5 years ago, it was all a big flat parking lot the size of many, many football fields. This all used to be port facilities in here, long since abandoned. This is the Conley Container Terminal. Logan Airport is over here. And then I was mentioning earlier Fort Point Channel right here. So really faces a really difficult problem. And unfortunately, many of the developments that are now being built there were licensed or permitted 5 or 6 or 8 or 10 years ago. The recession then slowed things down. We've learned so much more through this study and other work in the last 3 or 4 years that some of the developers doing the newer buildings are now doing them differently and elevating them and so on, and I'll come back to that also. But we now have a pretty big mishmash of some of the older buildings, just 5 years old, that didn't consider all this, and now some of the newer ones that are doing things differently. This, again, is Fort Point Channel, which provides that flood pathway into all the south end. Did anybody see the article about Whited Circle in the paper this morning? One of the next targeted developable areas in Boston. This is where the Olympics were going to be. We better get it right before we start doing anything there, and I'll come back to that question as well. And then here in Dorchester is a park, and this is a good news story where the city is actually renovating Joe Moakley Park, and they're going to build some resilience features into it as we go forward. Still with me? So now look at the difference here. This is the Seaport area, and this is only what has already been built, not including everything that's under construction down there. And here's where you see this problem of the monthly high tides, $9 billion worth of damage exposure. And then I'll quickly go through East Boston and then wrap up with the solution strategies. Then we'll have plenty of time for questions. This slide is actually way out of date. If I took this picture today, there would be all buildings across here. And they're all plywood at the moment because they don't have their final exterior on them. It's very different from the Seaport areas back in here. Those are sort of 200 or 250 feet high buildings. They're in the flight path of Logan Airport, so their height is restricted. Over here, it's all residential development, maybe 5, 6, 7 stories. It's undergoing a lot of development right now. It's vulnerable near term, but it has the advantage of having some topographic features that will protect it. This is the new Greenway, like the Greenway in downtown Boston. It's a new park that was built connecting parts of East Boston. Unfortunately, it's very low-lying. It's almost like an old railroad bed. And so you can see where, you know, the most vulnerable parts of this city are going forward. But unlike the seaport, the water will come in only a couple of places right there and right here. So you can think of opportunities to deal with those flooding problems in that flood pathway. Logan itself is actually elevated a few feet higher than a lot of East Boston, and Massport has already done a very good, solid assessment of all of their key facilities, and they are allocating $50 million over the next 3 to 5 years to upgrade and flood-proof all of their critical infrastructure. Logan is really important, not to just keep it in business for all of us, but if we ever have a big flood and a big storm, this is where the military and all the recovery operations have to come in. So they have a very special obligation to make sure Logan can operate and get back in business, you know, quite quickly. Mostly because this does not include the airport, but mostly because East Boston are much smaller structures. It's pretty much all residential. The actual damage losses could be less, but a very large percentage of the population would be affected. So then let me layer in a little bit of the future. You know, Boston has had 4 big planning studies. After doing no big planning for 50 years, they've had 4 big projects underway over the last year, one of which was Climate Ready Boston. The second is Go Boston 2030, which is a mobility and transportation study on the future. And then the third is Imagine Boston 2030, and this was the sort of citywide plan within which all the other planning studies will be integrated. And what's interesting here, let me go back, let's see. You know, Boston at one time had 800,000 people. That was before white flight to the suburbs, before various recessions and other economic declines in the city. We got down to about 560,000 in the 1980s. We're at 617 to 620, 30, somewhere in there right now. Expected to hit 650 or 670 by 2020, and then projected to even have more growth going forward. You know, a lot of the other gateway cities that are called the Worcesters, Springfields, et cetera, a lot of people are migrating to Boston. So where is that growth going to go as our population grows? Almost 40% of those opportunity growth areas, which is a euphemism for land that's undeveloped for whatever reasons, will be in these vulnerable flood areas. So if you take a look at Imagine Boston 2030, the areas that they have targeted for growth, primarily affordable housing and in mixed-use developments. I mentioned Whited Circle earlier. Another one that's now under contract is Suffolk Downs, which is the racetrack, is in a very vulnerable zone here. This is the Belle Isle Marsh, one of the last 2 remaining big marshes in Boston. The other is in the Neponset River down here. Our group felt that the marsh, because the water will be too deep, will probably cease to exist by about 2050, which means this whole area inland of it is then going to become vulnerable. It's the buffer zone. So already we have proposals for Suffolk Downs and Whited Circle. The city has pledged, fortunately, that if we're starting from scratch in these areas, we have an opportunity to do it right from the beginning, to make all the infrastructure, all the roads, all the power, water, and sewer, and so on lines servicing the areas resilient. Whether they will do that or not remains to be seen, but we have to keep a close eye on that. This area right here, 100 acres in South Boston, is where the new world headquarters of GE is located. There's a big parking lot around all that. Again, also very vulnerable from the Fort Point Channel area. And then Sullivan Square here is another one of these areas that you can probably fix because most of the water would come right in there. That's near the Schrafft's building. So then just to talk a little bit about what the strategies are going forward. And dealing with this problem, you want to work in layers. There's no one simple silver bullet here. You want to make sure you understand the science and that you update it every 3 to 5 years. You also want to go down and look at that Boston tide gauge and see what's really happening to the level of the harbor. You can obviously measure rainfall. So you want to track that and try to keep an eye on which one of those trajectories that we are actually on. You want to have a really strong outreach program to educate particularly the vulnerable communities and the waterfront areas in Boston about this problem so they're better prepared. You want to look at whether there are ways to protect the shoreline through either gray or green infrastructure. You want to make sure your infrastructure, as I've noted a number of times, is resilient as possible. And you want to adapt your buildings. Both new buildings, you want to design them right, and old buildings, you want to bring them up to speed over time. The good news about this issue is we do have time. We're talking about decades of here. The bad news is the rate of change seems to be accelerating. So again, you want to work in layers, do things along the waterfront to buffer the wave action and the rising seas. You want to make sure all your buildings are designed properly. You're going to have to look at zoning, different parts of town, and all that critical infrastructure, excuse me, you want to be sure you make as resilient as possible. Here's the science. As I mentioned, a key task is to update the science regularly. So the city plans to institutionalize the research group that we've created in an ongoing way. The real challenge here is we plan for flooding in the past based on historical maps. We don't use future-oriented maps. So the FEMA flood maps, which are the 100-year flood maps that everybody uses, are based on past evidence of storms. The storm of record in Boston is the blizzard of 1978, in February 1978, which the trouble with nor'easters that occur during that time of the year, they can last for several days, so they can go through several tidal cycles, and sooner or later, you get it at the high tide. That's the storm of record in Boston. There's a reason they use those, because if you want to go to court to challenge whether or not you're in the floodplain, a judge will be much more receptive to you showing past evidence than he will or she will picking out Bud Riss's probability chart of what might happen in the future. We have to figure out a way, though, to develop future-oriented flood maps. We're going to look more specifically at some of those areas I highlighted earlier around the city. The city has already put out some contracts for more detailed work in this East Boston area and Charlestown. I think I have some slides to show that. We're going to look at what kinds of structural solutions might be put along the coast in these areas. These are very urban areas, so the opportunities for the sort of living with shoreline approach that we'd all like to see are somewhat limited, but will vary around the waterfront. Whatever you do, we don't want to just build big, ugly gray walls that you can't walk on, can't see over, or use for other purposes. So the really important thing is to think about other multi-purposes of whatever we do in terms of protective structures. We have one advantage in that we have a 41-mile harbor walk around the entire inner harbor. So there may be some possibilities for using it in various places if we elevate it a bit. But just to go back, the challenges are quite different depending on the parts of the city. Here in East Boston, we have this flood pathway and this one. So it's much easier to think about how to do something here and here that can prevent all of this flooding back up in here. There are many new developments. As I said, if you were to go out in a boat right here and look across, all you'd see is plywood and Tyvek right now. But fortunately, most of their developers have elevated their buildings and put knee walls around the base so the floodwaters can't penetrate. So we're going to have to knit together some kind of coastal protection that will actually utilize those buildings and prevent the water from coming further inland. The seaport area is a very, very different problem because the whole area is flat. There's no topography. So you've got to think about, can we somehow put a ring around all of this? And what would that look like? And would it go in and out of all of these piers? Would it go all the way around here? How can we do it and, derive other values and public benefits from it? How much would it cost? We already know, what was that number, $25 billion of potential damage. Unfortunately, we can't just put some kind of structure across the Fort Point Channel because the land on both sides of it is very low. So you could build the highest dam in the wall right there, but the water's just going to come around it through the city, which is a problem with the Charles River Dam. The back bay will be subject to flooding. I didn't show any maps of that. Subject to flooding, as the water overtops the dam very late in the century. But you can't just elevate that dam because the land on either side of it is very low, all around North Station and Charlestown. And then the other thing that happens when I go talk to all the developers, they all say, well, yeah, I could do this, that to my building, and what about the infrastructure? And can't you just be like the Dutch? Just build that big dike in the outer harbor and protect us all, and wouldn't that be a cheaper way to go about all of this? So we're going to address that question. The Barr Foundation, through the Green Ribbon Commission, has actually funded UMass Boston and Arcadis, which is that Dutch engineering firm, to look at various ideas that have been around, some old, some new, for protecting Boston Harbor by putting something further out here in the outer harbor. This is the inner harbor here. One of the alignments that we're going to look at would go from Boston, from Logan Airport to Castle Island. This is where that container terminal is. Another goes from Deer Island, where the sewage treatment plant is, across to Long Island, and then to Quincy. This is where there was a Long Island bridge that was taken down a couple years ago. It was condemned. Another idea is to go all the way from Deer Island across the islands to Hull and all the way across into here. The big question, and then we're also going to be looking at, this is the national park, all these islands out here, they're all eroding naturally. That's really a problem because they provide defense to the city of Boston. So we're also going to look, are there green solutions that could be adapted to stem the erosion on those islands to bolster their capabilities. But there are many, many big questions here. The first is, what is it we're designing for? Is it something with big something with big gates like they would do in Europe that you would close when you get 24 hours notice of a hurricane coming? Or think of New Bedford. New Bedford has a big, can't think of what the rocks are called, big, huge rocks, riprap. Two big riprap walls with some gates in them, so when the storm comes, all the fishing boats go inside of that and they close the gates. There are many of those in the Netherlands and other European countries. Or are we designing for that incremental sea level rise that's going to happen every year and ultimately will start to affect us monthly or weekly or even daily at some point, or both, because one of those problems compounds the others. So, depending on what you're designed for, you have very different needs for these kinds of structures, be they either green or gray. You also have the big problem, yeah, you can put a barrier here, but won't the water just come all the way around in through Winthrop? Want to come all the way around, through Dorchester this way. Even if you do it here, you might come around through Quincy, and then maybe you end up building some kind of seawall all the way from Nahat all the way down to Situate. Take Marshfield, right. And you might as well go to Provincetown at that point, right? So, and then of course, depending on what you design it for, you run into all kinds of conflicts with other users of the harbor. So there's the Boston Harbor Islands National and State Park that a couple 100,000 people visit each year by ferry. We are a major commercial shipping harbor that we're in fact making deeper to 50 feet so we can handle bigger ships. And since we spent $6 billion cleaning up the harbor, it's clean and recreational boating is now booming. So you've got to think about all these kinds of things. And then there is water quality itself. If we think about restricting the tides are very important to flushing and keeping our harbor clean. What would happen if we start restricting the tides? And then you get this huge moral dilemma, yeah, but what's the point about worrying about water quality if we can't live there anymore? Because the waterfront's so dangerous. So these are huge questions. Any kind of project like this is probably 30 years from start to finish. Think of the Big Dig, which was like 18 years. This is in spades. So we thought it appropriate to at least let's ask the question, is something like this feasible? What kinds of problems might it cause? Roughly what might it cost? So at least we know, should we forget about it? Or should we say, yeah, this is something we should keep in mind longer term? But keeping in mind, even if you decided to do it, it's probably a 30-year project. Let's say we got started on 2025, we're already into that latter half of the century, which basically means don't sit back on your haunches and do nothing for the rest of the city, while we start to look at this. Still with me? I'm almost done. Here's the infrastructure issue. The key here is to establish uniform planning and design standards, which we do not have for infrastructure throughout the city. Coordinate all your infrastructure planning. And particularly you want to integrate resilience planning, as I said earlier, with your ongoing annual capital planning and financing cycles. So, if you're going to upgrade a power station, if you're going to upgrade a T station, look at ways that you could also make it resilient when you do that. There's unlikely to be a big pot of money to do it in any other way. The blessing Boston has of never having a Katrina and a Sandy is we've never had the damage from that. The curse is we don't get any federal disaster money. New York has over $1 billion that they're going to be using for that Big U project. You really need to focus on buildings, and the first thing to do when you dig yourself in a hole is stop digging. So from now on, where we site and design new buildings in any of these vulnerable areas, we want to be sure we get it right. That means looking at those forward-looking flood maps, not just the historical ones. Being very flexible with the way you design and use your first floor. This is the Spaulding Rehab Hospital over in Charlestown. It's in one of those vulnerable zones. There are no patient rooms or patient facilities on the first 2 floors. It's all upstairs. You want to make sure all your mechanical systems are up above, not down below, where they could be exposed in a flood. The big challenge, and this is now happening in Seaport, where some of the buildings are higher up than others, and the first floor is actually higher than the buildings next door, is how do you harmonize the sidewalks and the roads in between them? That's a big issue going forward. It's a big ADA issue for people with disabilities. It's going to require some really clever solutions as we work on that in the future. Going back and adapting older buildings, if you remember one of my earlier charts, something like 2/3 of the buildings in Boston that will have serious exposure to flooding are old triple deckers, either single occupancy or multiple tenants, either on-site or off-site landlords. That's going to be a big challenge going forward to particularly come up with financing to do that. The more we can make our power system resilient, not only can we then help mitigate the climate problem by using more efficient and greener technologies, but we also become more resilient should we ever have a big flood event. This is way too detailed, but just to let you know, there's this now roadmap that the city has. This is about 6 pages. I think there are 10 or 11 strategies overall, where they've outlined over the next 5 years and then the long term, what they're going to work on. They've established their priorities. I spent half my life in the last couple decades working on advisory committees all over the city. I'm always raising my hand saying, can we please end up with just the 3 bullets? Just give me the 3. It's really hard to do, and partly because it's a very complex problem. And then the most immediate projects that are now, most of which have funding. I mentioned that the city is leading this effort in East Boston and Charlestown to figure out how it can close off those vulnerable flood pathways and do so in a way that would provide other community benefits. They're about to let out a RFP for the Seaport 4-Point area to do exactly the same thing. So in 3 of those vulnerable areas, they'll now have more concrete work going underway to analyze the problem, figure out some solutions. The harbor-wide feasibility study has been funded. At some point in the next year or two, the BPDA, the Boston Planning and Development Agency, will start some kind of zoning process. And there, that gets back to that whole question of how do you develop a future-looking flood map. And then, of course, some of the big questions are, do we really have the governance structure in place to tackle this problem? Who would build the big barrier, for example? And then, of course, there are huge financing questions. So UMass Boston School of Government and the Business School is actually doing a study of this over the next year to outline some options for the city going forward. So I've been very impressed working closely with the city as a partner. They really sort of have moved into high gear on this subject. We were worried when it transitioned from Mayor Menino to Mayor Walsh, but just this year they put in a rather large capital request to do a lot of these studies and feasibility work. So they seem to be going forward. They're tough issues. Mayor Walsh is not going to get credit 40 years from now when Boston is saved from a flood. Who's ever the mayor at that time, will get all that credit. He probably also gets a lot of pushback from the real estate and development community. And we have found if you talk with and work with the developers who are here to stay, who are holding their buildings for a long time, there will really be strong partners in all this. The people who want to sell their buildings and flip it, 10 times in the next 50 years don't want to hear this, and that's understandable. So we have to somehow figure out how to engage them in this process. This is the new GE building where construction is soon going to start. This, in fact, is Fort Point Channel. So and that 100 acres empty land is behind here, which is one of the city's targeted growth areas. This whole site, these are the two existing buildings. The rest of the site slopes upward under the new building. It has this solar veil on top, so it will deal with the mitigation problem. And these will be the sort of living shoreline approach that I think will be a nice public benefit feature along there. Their whole first floor is, quote, expendable. It's a museum about the future. There are no offices in there, and there's no hardware, software. You know, all the top secrets of GE will be somewhere else. So I think it's going to be a real model. That the Spalding Hospital I showed you earlier has always been the poster child. I think this will be our new poster child going forward. Big mouthful, I'm sorry. I'm finished. Thank you.
This is great. Thank you so much. I think I had the privilege to see this presentation a few weeks ago, and I thought it would be fantastic to share with the GSD and the university and the public. So I'll open it up for discussions, but I just want to say a few things. I think it's so commendable just to see how complicated the topic is and how Bud made it so easy, right, to communicate. I think this is one of the challenges that we have with topics like this in terms of science and communicating that to ourselves as well as to the public. At the same time, or in addition to that, I wanted to say another thing, which is how complicated the topic of climate change in relation to its implication. This is one aspect of it, which is the sea rise, right? In addition to that, I was thinking, and as you know, there are issues that are related to energy implications in relation to buildings. We're moving now toward more buildings that are in harmony with our environment, which means that utilizing natural ventilation and temperatures and so on and so forth. As temperatures become so high and with their frequency increasing, as you told us, one of the things or the challenges that we will have is if we were to design such buildings, we will have really tough problems for us to be able to mitigate those buildings later on, right? So all of this push toward newer and higher degree of regulations, as well as stricter degree of regulations and performance-driven regulations and so on and so forth, it will be actually hindered by the topic of climate change if it hasn't been really taken into consideration seriously. So again, I think we've seen one example, complex example that you made so easy for us to understand, and I would like to open it up for people, sure, because I'm pretty sure there are so many questions.
Great, thank you. Yeah.
That was a great presentation. Thank you.
Thank you.
Where do you think we are in terms of public awareness and public understanding of this work? And I'm just thinking about all the homeowners that you pointed to,
sure,
who are going to need to do some mitigation. How are they being engaged in the process?
Yeah, it really varies throughout the city. And it's interesting. We're trying to decide early on how much public engagement to do on this project. And you know, one school of thought was, well, we're starting with the science technical stuff. Let's get that done and then go out in public. We all know better. You want to start early and get everybody's attention and involvement to understand the problem from the beginning. But what happened was the city was starting this big Imagine Boston 2030 project, which had 1,000 public meetings over the last year and a half. And that sort of exhausted the public engagement opportunities and all the people participating in those. So they embedded the climate discussion in some of that, not as fully as I would have liked. And then there are pockets. East Boston has been working on this issue for 4 or 5 years. There's a group called NOAA, Neighborhood for Affordable Housing, that a lot of it is along the waterfront. So they are really up to speed on this, probably the most educated in the city. I think the Seaport has learned very quickly, the developer and real estate community there. I gave a talk to one of the companies that is doing the big projects there this morning, and they said unquestionably their people now buying condos are asking the question about how vulnerable their buildings are. So that change is happening, but we have a long way to go. Just last night, the city started a new program. There's a much simpler version of this slideshow, and they are training people to give it in their neighborhoods all around town. The sort of Al Gore model of, you know, train 1,000 people to talk about climate, which is great. So we'll catch up.
So I understand how a seawall can deal with storm surges, but how about the water table? Won't just sea rise bring up the water table? So the seawall wouldn't do any good then?
It will, and that's another problem that we didn't get into, infiltration of salt water in the water table
Yeah.
all around the city. That's an issue in Cape Cod and, it's a big issue in Miami where they have a limestone foundation
Yeah,
for
yeah,
everything.
yeah.
So I don't think it's quite as acute here, but that could be, another problem we have to look at going forward.
And one thing that you didn't mention at all in this, probably because it's just too complicated, and that is the economic impact on real estate.
Yeah.
This is something that you read about when you're reading about Norfolk, Virginia. What happens when flood insurance goes away or becomes much more expensive? I don't suppose that you have any thoughts about that.
I have many thoughts about that. But, in simplest terms, I think one thing we have to do is create value around resilience. If you talk to 30-somethings, or if you talk to developers and building owners who are renting office space or apartments to the younger people coming into the city, they will tell you buildings that are greener because they're more efficient, because they don't have big parking garages, they have access to Hubway and Zipcar and all of that, have solar on the roof, are now commanding more rent money or more sale market value than conventional buildings. So if we could get to that in resilience, I think that would be really good, where buildings that are resilient have more value. The complicated part is, if your building's really energy efficient, you get a payback in lower energy bills every year. You don't get payback here until the storm comes, and then your payback is avoided damage. So that's why the financing is much, much trickier. But when I talk to the real estate community, I don't lead with regulation because that won't get you very far. But if you start talking about how can we give you incentives to do the right thing and create more values around their buildings. I had a great idea that lasted for 5 minutes in one meeting, which was, like the fuel economy sticker on a car when you go buy it. Why not just put a sticker on the outside building? I'm in the 100 floodplain, or I'm not in the 100-year floodplain. They didn't want to hear that one at all, But so I can't see. So if somebody has a hand up, shout. Yeah, hi.
Hi. So I had also a question regarding the coordination with other municipalities around Boston. I mean, a lot of these strategies have to be regional in terms of figuring it out. I know locally they'll probably be implemented by Boston, but I was wondering what the strategy is in terms of coordinating with Cambridge, Brookline, looking at it more at a regional level. And I know MAPC has been doing some work around this, but
there are a few things. So there's the Metro Mayors Coalition, which is, I think, 14 cities and towns, most of which are on that map, including Cambridge and Somerville. And they meet together on this subject. Boston, because of its size and its financial power, obviously is, much more has much more resources to devote to the problem versus Quincy and other towns are much smaller. But they are part of that group. For this project, we created an infrastructure advisory committee, which includes public agencies from many of those municipalities, as well as the state and the region. And then for the barrier study, we have pulled in all those towns that might be affected, might be inside or outside the barrier, but you might have to take the gravel trucks through their town to get there. So they're going to be involved in this work also, but it needs to get bigger. And then the good news is the state, the governor put out an executive order about 6 months ago that is requiring all state agencies to do statewide vulnerability assessments. So I think the level of involvement will grow over time.
Great.
But water knows no boundaries. So, and even on the East Boston study that I showed, where we're looking at how to stop the flood pathway that would affect Charlestown and Sullivan Square, a good part of Somerville is exposed there, so Somerville is part of that work also.
Great, thank you. Because my follow-up was really on watershed level initiatives, and if you've been coordinating with watershed associations, and great, thank you.
And Cambridge has done a lot of leading work on this subject also. Yep.
I've got two questions. The first is, I was surprised when you mentioned that the seaport area had buildings only 5 years old, which were not thinking about resilience, and I was wondering what your take on the psychology of that is.
Yeah.
And the other is a sort of a much bigger and perhaps unanswerable question about mitigation versus resilience. And your graphs had, you know, a couple of scenarios, the worst case, the semi-worst case, etc. And it's a global world, but, you know, the city has got resources, and is there a calculus where they could spend those resources on mitigation as opposed to resilience?
There is a big program on mitigation in the city that actually started before this, and it's there's a new modeling effort underway, whole different subject matter, but this kind of framework to figure out where the city should focus more going forward. There are big questions there because a lot of what the city does on the mitigation side is dependent on what the state and the federal government does. So by the feds relaxing the fuel economy standards, that puts a bigger onus on what we might do here. By the Fed relaxing the new power plant program and all of that, puts a bigger onus on trying to do something here. So we're kind of re-looking at all of that. And then the first question is why, you know, if the seaport started building just 4 or 5 years ago, weren't they more up to speed? Because they started the permitting process for those buildings probably 15 years ago. And once they got a certain momentum going in that area, and then the recession hit, and the mayor at the time, who was Menino, and the Boston Redevelopment Agency were anxious to stimulate development there, so they kind of let them get going and sort of, you know, build every square foot as cheaply as they could to sort of stimulate growth there. And it's unfortunate because not only is it now very vulnerable, but it's kind of really poor planning, you know, from a public benefits and enjoyment point of view and from a civic point of view. So we learned a lot of lessons in the seaport that I hope we're not going to repeat elsewhere. So, but keep an eye on that Wyatt Circle and Suffolk Downs. We'll see. Yes, sir.
Hello, thank you for your talk.
Yep.
I wanted to ask if you could talk a little bit more about the role of scenario planning in the resilience plan. And what I was thinking about was in their early assessments, the IPCC would explore different emissions scenarios, and they'd look at different drivers of change, like whether governance would be globally oriented or locally oriented, or the role of technology, in order to develop these kind of different storylines for development. Here in this school, like, we have a lot of freedom to kind of explore potential scenarios, and the population projections in your presentation seemed a little business as usual to me, that like we're expecting 100,000 people, the real estate market will continue to be hot, and so we need to sort of plan around that. And I wondered...
I think we've learned that lesson a few times too, right?
Yeah, and so I wondered within this process, to what extent were alternative visions or alternative futures explored, and what you think about that, whether this project can kind of absorb that kind of thinking, and whether it would be useful or not.
Yeah, we only, quite honestly, we only did scenario planning on these different sea level rise scenarios, and that's really all about what level of risk are you or is anybody willing to take. You know, you got to sort of pick one at some point. We didn't look at scenarios around demographic or any of the economic projections because we just felt they were too uncertain. But maybe that would be a good follow-up project for somebody to do. Not a very sophisticated answer, but great.
Thank you so much.
You're welcome.
Thanks
Thank you.
again. Thanks
Okay.
on behalf of Harvard. Thank you so much.
You're welcome.
Thanks. Thank you, guys. And until the next lecture, thank you so much.